Hi students, today we're going over Unit 1, Module 1, Session 2, What's the Problem? Let's go ahead and take a look at the example together. It says, to find 3 times any number, Maria doubles the number, then adds the number again. A says write an expression with parentheses to show how Maria would solve 3 times 6. So we see that she wrote or drew parentheses 2 times 6 and then added 6 to solve the problem. Then asks, what is 3 times 6? We see the problem is, or the answer is 18. And then C, what is another way to think about 3 times 6? And the student wrote, you could do 3 times 5, which is really easy. Then add 3 more like this. 3 times 5 plus 3. So let's now look at the first one together. Number 1 says, find 4 times any number. Susan doubles or uses the double-double strategy. Multiply by 2, then by 2 again. Because we know that when we double, it's really multiplying by 2. We're taking that number and we're adding it to itself. We're doubling it. And so the double-double would be multiply by 2, then by 2 again. So Susan wrote 2 times 9 times 2 to record how she would solve 4 times 9. Because what is 2 times 2? That's right, 2 times 2 is 4. So to solve 4 times 9, she broke up that 4 and she was like, oh, that's double-double. So now we're thinking, what is 4 times 9? And we know 4 times 9 is, that's right, 36. And then B says, what is another way to solve 4 times 9? So maybe you can break up that 9 and you can think 4 times 9 is 4 times 4 plus 4 times 5. And then we know that 4 times 4 is 16 and 4 times 5 is 20. So then we're thinking 16 plus 20 equals 36. So that's another way of thinking of 4 times 9. Now let's look at number 2. Number 2 says to find 5 times any number, Kaylee first multiplies by 10 and then finds half the product. So it says write an expression with parentheses to show how Kaylee would solve 7 times 5. So again, 5 times any number, I can think that is the same as multiplying by 10 and then finding half the product. Why? Because 5 is half of 10. So now I'm going to write an expression to show this thinking. So I would do 7 times 10 divided by 2. Because when I multiply by 5, it's the same as multiplying by 10, then dividing by 2. So thinking of that, 7 times 10 is 70, divided by, oops, I wrote 5, but I meant to write 2. So let's erase that. Sorry about that. That should be 2. 7 times 10 is 70, divided by 2 is 35. So what is 7 times 5? It's 35. What is another way we could solve 7 times 5 besides thinking about that 5 is half of 10? So again, we could break up this 7 and we can think 7 is the same as 5 plus 2. So then we could do 7. We could do 5 times 5. Add that to 2 times 5. So again, my thinking is that 7 I broke up to be 5 and 2, because I know 5 plus 2 equals 7. So I thought 5 times 5 plus 2 times 5. And I know 5 times 5 is 25. And then 2 times 5 is 10. So 25 plus 10 equals 35. There may be another way to think about it too. So feel free to add your own thinking down if you thought of another way. Number 3, when given any number times 9, Jasper multiplies the number by 10 and then removes one group of the number. So write an expression with parentheses to show how Jasper would solve 3 times 9. So again, up here it says we are going to multiply by 10 and then remove one group. So showing Jasper's thinking, it would look probably something like this. 3 times 10, and then taking away a group of 3. So you could just subtract 3, or you could actually write down 3 times 1 because we're showing that that's one group of 3. So what is 3 times 9? Well, I know this is 30, and 30 minus 3 is 27. What is another way to think of 3 times 9? So you can break up this 9 to be 5 and 4. So we can think 3 times 5 plus 3 times 4. And I know that 3 times 5 is 15, and 3 times 4 is 12. So 15 plus 12 equals 27. And again, there's probably another way you can think about that. So feel free to add that on your page. Going now to number 4, it says Braden loves multiplying by 8 because he can double, double, double. So just like on the previous page, we know that when we double, it's multiplying by 2. So double is times 2, double again times 2, double again times 2. Thinking, what is 2 times 2 times 2? Well, 2 times 2 is 4. And take that 4 and multiply by 2 again, or double again, and that is 8. That's right. So anytime you see a problem that's multiplied by 8, you can simply think of it as double, double, double. So it's saying write an expression with parentheses to show how Braden would solve 8 times 7. So perhaps Braden thought about this. I'm actually looking at what the problem is because the problem doesn't state it up here, right? It says Braden loves multiplying by 8 because he can double, double, double. But I can look down here at B and it says 8 times 7. So it looks like he's multiplying 7 by 8. So to show that double, double, double. Oh, sorry. It actually says it right here, doesn't it? I did not look fully at the problem right there. So 8 times 7. So we're going to do 7 times 2. And then we're going to take that and we're going to double it again times 2. And then we're going to take that and we're going to double it a third time. I said third time and I wrote 3, but I meant to write 2. So again, that's double, double, double. 7 doubled is 14. 14 doubled is 28. 28 doubled is, that's right, 56. So 8 times 7 is 56. C asks us, what is another way to think about 8 times 7? Perhaps you can think of it as 4 times 7 doubled. Since 8 is the same as 4 times 2. So 4 times 7 is 28. 28 doubled is 56. Let's now look at number 5. Jonah was asked to add 4 and 7, then multiply the sum by 9. Which expression shows Jonah's problem? So he was asked to add 4 and 7, and then multiply the sum by 9. Is this add 4 and 7? Yes. Is this add 4 and 7? No. Is this add 4 and 7? Yes, but I see the parentheses are here, and that's not where I would want the parentheses. So I already can eliminate B. It's not B because that's not adding 4 and 7. So now looking at my two options, is it A or is it C? Well, I see it here on A, the parentheses are in the first part of the problem, and so I would say A is correct because the key part of my question says then multiply the sum by 9. That gives me a clue that the answer is A. Looking now at number 6, says Patrick needed to multiply 4 and 6, then subtract 12 from the product. Write an expression with parentheses to show the problem. The product, as a reminder, is the answer to a multiplication problem. So he needs to multiply 4 and 6, then subtract 12 from the product. So multiplying 4 and 6 would look like this. Then subtract 12 would look like this. Parentheses are not required due to the order of operations, but we haven't really talked a whole lot about order of operations. But just in case you'd like a little bonus tidbit of information, order of operations is commonly referred to as PEMDAS. These are our orders of operations, and PEMDAS stands for parentheses, exponents, multiplication, division, addition, and subtraction. And this is the order in which you complete an expression when you see something like this. You would solve multiplication before you would solve subtraction. So the parentheses aren't really necessary, but we're going to keep them there just for clarification. And number 7, it says, Violet divided 81 by 9, then multiplied the quotient by 3. Write an expression with parentheses to show the problem. And as a reminder, the quotient is the answer to a division problem. So Violet divided 81 by 9. So I'm taking 81 and it's divided by 9. And then she multiplied this quotient by 3. So we have parentheses. We see that division sign showing me that it was divided, and a multiplication sign showing that it was multiplied. And then for number 8, it says solve 54 minus 3 times 8. The parentheses are here around the 3 times 8, so we need to solve that first. So we'd say 3 times 8 is 24. So really our problem is 54 minus 24, which equals, that's right, 30. Looking at B, 28 divided by 7 times 4. So again, I see these parentheses. That clues me in. I need to solve 28 divided by 7 first, which 28 divided by 7 is 4. 4 times 4 equals 16. There's my answer. And then for the challenge, it says, Raphael was given the problem 44 times 9. Write an expression to show how you would solve this problem. So really, boys and girls, there's not an incorrect answer because you're just going to write down an expression to show how you would solve this problem. So there's several different ways you could solve the problem. Honestly, for myself, probably what I would use is I would think that 44 times 9 is the same as 44 times 10, and then I would subtract a group of 44. So if I were to write an expression to show that thinking, I would say 44 times 10 minus that one group of 44. And it doesn't actually tell us we have to solve the problem. We're just going to write an expression because I know an expression does not have that answer. An equation does. But I'm going to probably go ahead and complete the problem just to be on the safe side. So 44 times 10 is 440. 44 times 1 is 44. And 440 minus 44 equals 396. And that's all for today.